Now let's look at this example. It says the diagram below shows a bolt opener. Guys, state the principle of moments. The principle of moments states that clockwise moments must be equal to anti-clockwise moments in an equilibrium state. It also says the downwards moment to be equal to the upwards moment. They're just the same. Then B says calculate the force F needed to remove the bolt top. So the force F is there. Now you need to choose which one is the pivot. Is it this part or this part? If we choose this part to be the pivot, so what are we saying? Now where is the turning point whenever you're opening a bolt opener? Is it here or here? If let's say the turning effect is here, that means just here, that's where our pivot will be. So if this is our turning effect, that's where the pivot is. So we need to get the distance of this force from the pivot and this one from the pivot. So remember that F1 times distance 1 should be equal to F2 times distance 2. This is the principle of moments. Now F1 is 500 newtons times, then the distance 1 is this from the pivot, which is 2 centimeters. Then this F, we call it F2. The distance of this one from the pivot is 2 plus 10, which is 12 centimeters. Now take note the distance is in centimeters, so there's no problem here unless you've been asked to find a single moment like this. That's when you can change your distance into meters. So we're going to divide by 12 centimeters this side, by 12 centimeters, so that you can remain with F2. And this will give you 250 newtons. Can this be true? Yes. The shorter the distance, the longer, the more the effort. The longer the distance, the less the effort. So we are certain that this answer is correct. That's the principle of moment, and this is the force. Thank you.